Hello, Keith Rucker here at VintageMachinery.org. Guys, today, back working over here on the horizontal boring mill, we are getting really close to having every little thing done I need for my first job. I got one more little shop made thing I need to do plus the job today. And I think we're gonna be ready for our first job. And what I'm gonna work on today is this crank handle that's used for making adjustments on this mill. When I got it, it had a handle this down there on the floor. It was a homemade thing. It worked, but it really was not the ideal situation. I don't remember off the top of my head, but a viewer was kind enough to send me a crank handle that I'm pretty sure was original to a Lucas mill. It's the same spline configuration that fits in here and has the right offset on it to clear all the settings and everything. I'm pretty sure this was an original one. However, this one has been modified. It's been shortened a little bit and it's really not ideal. And what I want to do is make a modification to it. We're going to keep the handle, but we're going to make a little mod to it to make it a little bit more usable on the machine. So let me show you how this thing works and let me show you what I need and what the problem is and how we're going to go about fixing it. So there are multiple places on this machine where we have the little spindles coming out where adjustments can be made. And for example, right here, you put the handle in. This one adjusts the table in and out. This one adjusts the head up and down. There's one over on the cross feed on the table to adjust the in and out of the table. And there's three of these over on the back. One that adjusts pretty much all three axes here on the end of the tailstock down there. But here's the problem. You see how long this stud is that sticks out. And when you slide this up on there, notice it's not flush with the end. Right now, when you come around here, boom, it's interfering with some of these pieces here. If this was out here at the end, it clears perfectly. So what looks like has happened is this, my thought is this thing has gotten worn over the years and they've kept milling it shorter and shorter and shorter to get good teeth on the end. And right now it's so short that we've got interference. What I want to do is come in here and actually make a little section to go on here. And I think we're just going to weld it onto, or I think this may be cast iron, so we might braze it on there, but still weld it, braze it, whatever, to get that little extension out where we have the clearance that we need. Have the same problem over on the end of the tailstock or end of the bed. It interferes with the other ones. There's three of these that are right by one another, and you need that same clearance to be able to, for the handle to clear. So that is the game plan. Just showing the ones here at the end of the bed, and it's got the same problem. You come around here and that hits. We come out to the end where it should be and it clears. So we just need to add a little extension in there, give us a little bit more room. This is the spline that we got to match. This is actually one that I made. I have remade two of these that were just so worn out that I replaced them while we were rebuilding this machine. And eventually, if I tear into some of these other areas, I may replace more of these over on the other end as well. There's some of those are a little bit worn as well, but they're still working right now. But if I do ever have to tear in there, I'll probably just replace them and make new ones. But let me talk about this. So there are 7 splines in this. I'm calling it a spline. And it's more or less is 7 splines in here, which is it's an odd number. Divisions is going to be not too challenging, but you know, it's not really going to be like an even number of degrees between settings on here. We'll probably end up cutting these using my dividing head rather than a rotary table, just because of it'll make the math a little bit easier. And basically, you know, what we got to do here is we got to make the opposite of this. And it is a little bit different setup because with this we used a horizontal milling machine with a cutter that had a 30-degree included angle on it. With this, because we're milling on the top, it's not really an option. You can't, you know, if we were milling this way it'd be one thing, but you know, with us milling across the top, it's a little bit different. and we're basically removing the material here and leaving the hole. So it's kind of the opposite of this. We are going to actually, like I said, do this over on the vertical mill. We'll use dividing head to make our divisions, and it's not just as easy as making a straight cut through here. There is a 30-degree included angle, so 15 degrees on either side of this to get that right. A little bit complicated. You're actually going to have to make 3 passes around to get everything removed, and you'll see that as we get over there. But first step is basically I need to make the piece that is going to weld on here. So we need a piece probably about 1.25 inches long. I'll go around to my other ones and just measure them and confirm that to weld on here. And actually, because of that little indentation down there, it probably needs to be, that's another, 3/8 of an inch or whatever deep. I'll figure up how long it needs to be. We're going to go ahead and get the blank turned over on the lathe, and then we'll go to the milling machine and start cutting this stuff out. And like I said, once we do all that, we will weld it all together and put a little extension on this handle to make it more useful. All right, I think I got a little sketch here of what we need. So 1.5 inches long, a little less than 1 5/8. It actually looks like this was originally 1 5/8 and they turned it down to 1.605. We're going to match that diameter. So just a little under 1 5/8. Like I said, total length is 1.5 inches. This is not to scale, and we'll make this little step on the end. That's 3/8 inch deep, 1.155 in diameter, and then there's a 7/8 inch hole drilled all the way through. I'll probably drill it just a little bit undersized, and then at the very end, we'll just run a drill bit down through there and clean it up so everything lines up perfectly with the existing hole. So let's go over to the lathe and see if we can get this little part knocked out. Over at the metal lathe, Monarch Model K 16-inch metal lathe, and we're going to go ahead and start turning this down. So I'll start by facing the end. It's just a saw cut there. We'll turn this down to, what was it, 1 5/8, a little less than, about 1.5 inches deep. All right, we'll touch off here. And just face that end. Might have cleaned up. We'll take a look at it here just a sec. Yep. Zero out my Z-axis. I need to go in 1.5 inches, which is about right there. I'm just going to put a mark where I'll know how far I got to turn down. We'll go a little past that. And see where we're starting at. We're at about 1 inch, 1 inch, 1 7/8 inches. So we've got about 250 thousandths to take off of this. And touch off here. I'm just going to take about 200 thousandths. Go a little past the mark there. Looked like it moved in a little bit. I'm going to just slide it back out a little bit and tighten that chuck up real good. And we got about 50 thousandths still to come off of that. Actually went over a little over 150 here. We're just going to go ahead and take this off, and we should have another little cleanup pass to make. Let's see what we got here. Some tough metal. Need about 15 thou more. All right, that should be the final diameter there. I'm gonna come in here and touch back off on the end and zero my Z-axis. That needs to go down to 1.155 and about 3/8 deep. So I'll go ahead and dial in my 3/8, which is that's about how deep we need to turn that little stub. And we'll start cutting it in there. That's about 155 right there. I'm gonna get down to the bottom, and I'm gonna pull it out so we have a nice square finish there. And that should have to take this a little bit more, it looks like, to get it to fit up on there. I don't know, it's gonna go. Yeah, it fits right up on there. 7/8 hole is what we're going after. I'm gonna drill it one size under 7/8. We'll clean it all up at the end once we get it welded together, make sure it's aligned good. 55/64 is what I'm gonna go with. Right now, we're just gonna start by putting a center hole in here. This will just help my drill bit find the center. I don't need much. Just a little dimple to get that bit started. I'm going to start with a 3/8 inch drill just to kind of get a hole started in there. I got a mark on my drill bit where I want to go to, and I am just clearing those chips out as I get down in there. All right, that should be plenty deep enough. Slowed my spindle down just a little bit there for this size drill. We're about 350 RPMs. Again, this is 55/64, which is just a little under 7/8. All right, we are all the way down to the bottom of that hole. And I also want to come in here and just want to break that corner. Just kind of help it get started. This one here, this is going to be a welded seam here. So I'm going to chamfer this pretty heavily. That'll give me a kind of a weld prep. I still got a shoulder down there in the bottom, but I got plenty of room there for my weld to take that up. And I think we are ready to part this off or cut it off. We'll try parting it. Let's get a parting tool. This needs to be 1.5 inches long. It's not a critical measurement. I'm just going to use something across the face here. I'm going to just set the corner of my parting tool up against that. I'll zero my digital readout. And now I can just dial in 1.5 inches, which is about right there. And we'll just part that off. To go a little bit into the larger diameter there, but no big deal. Just got a little piece of stock here. I'm just going to catch that when it comes off. There we go. And I think we're done with our lathe work anyway. We've still got some milling to do. Let's go get set up for that. Guys, I said I was done with the lathe, but then I realized that I got one thing I need left to do, and that is I need to counterbore on the inside of this down, about 300 thousandths, just to give some clearance for those teeth so they don't bottom out on that shaft. The little splines are not to the same full depth as the bore, so we just need a little clearance in there. So here's what we're going to do. I'm going to come in here, I'm going to touch off on this surface, zero my digital readout. I'm going to go about, let's just say 325 thousandths deep, which should be more than what I need. And as far as that inside diameter, it's not critical. I just need a little clearance in there. So we're just going to bore it out a little bit. So we'll come in, touch off, and we're just going to start taking a little out. Again, 325 is my goal, my target on my depth. I'm just watching that on the digital readout. We're going to take another little pass here. Over at my Wells Index vertical mill machine now, and we're getting ready to start cutting those teeth in there. As I said, we're going to use the dividing head to make our divisions for this. I've got a super spacer. I've been using it in the last couple of videos. You may ask, why am I not using that? Why am I using the dividing head instead? I could use the super spacer, but it is based off of degrees rather than divisions. The dividing head is actually for making a certain number of divisions, and you really don't pay attention to how many degrees it is. The reason I'm not going to use a super spacer is because with 7 divisions, you take 360 degrees, divide it by 7, it comes out to 51.4285714. It's a very precise number, and it's not something that's very easy to indicate in on a rotary table that only has increments at 1 degree increments. With a dividing head, I go in here in my plates. I don't have to worry about how many degrees. It's going to come out right. And if I was just going to be making one turnaround, I probably wouldn't worry about it because the error probably wouldn't be that bad. I could estimate it. But we're going to be making probably at least 3 total revolutions in this because we're going to have to make 3 different cuts. And if there is any error, that error is going to compound for every revolution, and eventually it's going to get farther and farther off each time. I just felt like the dividing head was a better solution. We could have gone the other way. It probably would have worked just fine. Now I've got my Kearney Tracker Model H dividing head here. This is the smaller of my 2 dividing heads that I have. This one's a 40-to-1 ratio. Normally it is set with the chuck is at a right angle in this direction. It is adjustable though. You just loosen up these 2 bolts right here and you can rotate the head to whatever angle. There's a scale in here. I've got it set on I think 90 degrees is where I'm at right now, straight up and down. I've already got this centered up over here on the spindle. The way I did that is just use an edge finder, went and found both sides of the circle and calculated the center and then did the other axis. Didn't bother showing that on the video, but we've shown that a million times. So we're going to start by coming in here and making our 7 straight cuts. I'm going to show you a picture. In fact, let me just go ahead and zoom you in on this and show you this and kind of explain the operations that we're going to be doing here. So I've kind of sketched out that whole pattern that we're going to be doing. The areas that are kind of open are the ones that I'm going to be removing as we go through here. And again, it's not a straight cut across. It's a 30-degree included angle across both sides. So we're going to have to make 3 passes. The first pass is just going to be a straight cut down the center. Once I cut all 7 of those, then what I'm going to do is I'm going to actually turn the dividing head back 15 degrees. I will do that by changing my plates, going to 24 divisions, because 360 degrees divided by 15 comes out to 24 divisions. So that's, you know, and I can use a different plate. With the same plate, different hole circles. So 49, for the 7 divisions on this, I'm using the 49 circle, 5 turns, 35 holes. For the 15 degrees, which is 24 divisions, I use a 39 circle, 1 turn, 26 holes. So I will rotate that head 15 degrees, and I'm going to probably have to adjust my axis a little bit, but I'll go in there and I'll cut 1 angle. And then I'll come back and I'll actually increment it back the 30 degrees, which would be 15 plus 15, and I will cut the other angle, and that will get our tapers on both sides, and hopefully after 3 passes we'll have all this done. So you can kind of see what we got here. I'm ready to roll. Basically the small end of this needs to be around 250 thousandths. The large side, once we cut the tapers in there, is going to be around 350 thousandths. These are not exact measurements, just kind of getting close. So let's get in here and start making some cuts. So I think we're about ready to go here. I've got my cutter set up right now in the very center, and I have that all zeroed out on my digital readout so I can go back there when I'm ready to, if I need to. I need for my depth of cut to be about 300 thousandths. So what I'm going to do is we're going to cut off this front side up here. So I'm just going to unlock my table. I'm going to come in here and I'm just going to drop my cutter down till it just touches. We're going to come back off. That will be my 0 on my Z-axis. And then I'm just going to raise my table up 300 thousandths. And that will get me to my total depth. And let's see, that should be about right there. I'll lock that height on that table. Put a little dab of oil in there. And we're just gonna feed out and let that cut it straight out. Okay, now we're going to index our part in 5 turns, 35 holes. 1, 2, 3, 4, 5, and 35. Should put us on our next place here. Same thing again. I've got this little scepter set for the 35 holes. Make it a little bit easier. 1, 2, 3, 4, 5, and I just go back around over here. Click in there. Lock my spindle. Give me a little bit of oil. And here we go. This should be the last straight slot. So with my first round cut, now I need to turn the dividing head 15 degrees one way or the other. And to do that, I need to change the plate, or not the plate, but change the circle in the plate that I'm using. Right now I'm using the 49 hole circle. I need to go to the 39 hole circle, which is the second one from the bottom. So to do that, we'll just loosen up this little spring-loaded piece, and I'm just going to slide it down to the circle it needs. I'll drop my pin in place, and to index it 1/24th of a circle, which will be 15 degrees, I need to go 1 turn in 26 holes. Now I'm going to start by going backwards. Normally I turn this thing clockwise. I'm going to turn it counterclockwise this first time. The next time we'll go back clockwise. So, and I'm not going to use the scepter here. I'm just going to count my holes, my pins, since I've only got to make 1 division. So we're going to go 1 turn and then 26 holes. So I'm just going to count them out. 1, 2, 3, 4, 5, 24, 25, 26. All right. So that has turned this. Now what I've got to do is I need to, well, first thing I need to do is figure out which side we're going to cut on. All right, so we have turned our angle 15 degrees, but now our cutter is not lined up. We're not going to be on the center anymore. What I'm trying to do here, guys, is the bottom end of this is about where it needs to be, about 250 thousandths. The top side, again, is going to come out to about 350 thousandths. So we're going to be widening out the top. So here's what we're going to do. I'm going to unlock my table. I've got my DRO set, so I can go back to my 0, but I want basically to kind of get this cutter. Let me see if I can turn that around just a little bit. There we go. I want this cutter to be more or less touching on the inside. We're going to be cutting off of this tooth right here, coming straight out and getting that angle cut in there. So that is about where I want it. There is a little bit of fudge work here going on. It's not a very precise thing, and I'm going to probably have to do some filing or even put it back on the mill to fine tune things once we get it over there to make it kind of fit like it needs to, but this will be a good starting point. I think this will work. I'm going to lock my table down, and we're going to come back around and do that again. So now I'm going to change my plate on the dividing head to where I'm doing the 7 divisions again, and we'll go around and we'll cut all those, and once we do that, we're going to go back to the center again, back to 0, and then we'll cut the other direction. So anyway, we're at the 15 degrees right now, and we're going to make 7 more cuts just like this. We're widening out that, or getting that angle cut on that side. And now let's do our 7 divisions. So it'll be 5 turns, 35 holes again. 1, 2, 3, 4, 5. And that should put us on the next tooth. And that is back where we started. All right, so we are back where we were a minute ago when we made our 15-degree adjustment. So we need to go back 1 turn and 26 holes, which will put me back into the 0 slot here. So I'm just going to go ahead and move this back down to the 39 circle, which is, tighten that back up. And again, it'll be 1, that's 1 turn, and then I'm going to end up back in the holes I started with at the top here. Okay, and that's got me lined back up here at the top. Now I need to go 1 turn and 26 holes in a clockwise direction to get 15 degrees in the other direction. So we go 1 turn, and I'm going to just count these out again. 1, 2, 3, 4, 5, 24, 25, 26. That's got me going my 26 or 15 degrees in the other direction. Now I need to move my pin back to the 49 hole so that I can do my 7 divisions again, just like we did a while ago. So we'll loosen this up, slide this. All right, and I want to basically get my cutter lined up on that side, which looks like it's about right there. And we will go ahead and make our rounds one more time. This should be the last pass. Like I said, we may have to do some fine adjusting, but this should be getting us close. So, one, two, three, four, five. All right, that should be about where we started. So there is the finished piece. And I did have to go ahead and bore this out to the 7/8 for this to slide up on there. Let's see how it goes. This is one of the ones that I made, and that is about as perfect of a fit as you can get. I'm very happy with that. There's more play in the gear than there is in the fit here. So this is one of the brand new ones. Let's go check the old original ones, the ones that I didn't make. So again, these are the old original ones. There is a lot of wear in them, but a little bit of slop in there, but that's mostly just from 100 years of cranking on these handles. These actually engage deeper than the handle that I had. I'm happy with that, and I think that's going to be just fine as well. That's better than what we had, so I think we're good. We're getting ready to go weld that onto the old pin or old crank handle. So again, just take another look here. Next step is I need to get this ready to weld. And before I do, this is the original, of course, and I want to get these teeth off of there. So I've got a nice flat background or back there to weld up against. I think what I'm going to do is just take this over to the belt sander and just knock that off real quick. I'm going to be the quickest, fastest way to get it out. And we'll then go in there and weld the new piece on the end, get that extension in there like it needs to be. I did, there's a couple of holes. I drilled into a couple of tabs. I took that over to my drill press. I was trying to determine if this one was cast iron or steel. The handle is obviously cast iron. It's been welded, brazed, tigged. Looks like it was tigged. That may be bronze. I can't tell. But it was welded on here at some point in time. And I wasn't sure if this was cast iron or whether this was steel. But based on the chip that came out of that, I got a nice long stringy chip. That's typically what you'll see with steel. With cast iron, you tend to get little flakes coming out. So we'll actually be able to weld this. I'm probably just going to use the TIG welder and TIG that up. So I'm going to take this over to the belt sander. We'll knock those old teeth off. I'm over here at one of the most used machines in my shop, which is this old Porter cable belt sander, and we'll knock these teeth off of there. Easy peasy. I'm gonna go ahead and put a little weld prep in here as well. All right, I think we are ready and set up to do some TIG welding over here. Guys, I'm gonna just tell you right now, I'm not a expert welder by any stretch of the imagination, but I think I can get this done without any problem. So I'm gonna probably tack it first, a couple places, and then we'll see if we can weld that in there. Start by just slowly putting some heat into it. I'm going to flip it over to the other side. Just want to make sure we're getting this kind of done evenly. All right, I changed my setup just a little bit here. Just put it in a vise so that I could get to this bottom side. And we're going to go ahead and fill that in. All right, I'm over at the radial drill now. And what I want to do is just pass the drill bit down through this just to make sure everything's aligned up on that center hole. So I've got my drill bit in here. This is like a 7/8 inch drill bit. And we're just going to go all the way through it. I'm just feeding this by hand. And we're all the way through. All right. And here we go. This is the moment of truth. We're going to put this in here. And look at there. That now clears those handles. That's exactly what I need. Fits good. I'm happy. There's the ticket. I think I'm going to go ahead and give this thing a nice new coat of paint. I might paint it yellow just because it's one of those things you're always looking for it. It's never where it's supposed to be. And maybe if I painted a bright color, it'd be easier to spot in the shop. So with that, I think we got this job done. Well, there we go. Not a super high critical thing to get this machine up and running, but something that's been on my list for a while. Glad to have that knocked out. That's going to make operating this machine a heck of a lot easier. And like I said, I got one more thing I got to make up here is a little dog plate to fit up on this spindle. And we're going to be ready to use this for the first job. And it's going to be kind of an unconventional job for a horizontal boring mill, but we're going to use it for it. And I think you guys will enjoy that when the time comes, hopefully soon. So like I said, one more thing we got to make, and then off to our first project. Guys, with that, that's going to be a wrap. As always, thank you so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. It helps feed the algorithms over on YouTube, which really helps get our site out there and found by others. And big, huge thank you all supporters of the site out there. Hit that subscribe button if you haven't already, that bell icon to get notifications when new videos are posted. And with that, guys, we're going to sign off. As always, thanks again for watching. We'll talk to you later.